Assalamualaikum. I will present my team research paper with title Performance Evaluation of Single-Phase Transformerless Inverter for Grid Photovoltaic Application. Let me introduce my team member. My name Muhammad Zulkifli bin Abdul Rahman and Muhammad Faizul Cikmat from Department of Electrical Engineering PSMZA. So for the introduction, due to the low cost and high performance characteristic, grid-connected transformerless photovoltaic inverter have been popularized in the residential market for the application of solar power generation system. Before this, the system used the transformer to transfer power generated to the grid. Now the problem statement is the technology of transformerless inverter PV inverter system generate a high leakage current between PV array and the ground. The high leakage current may damage the equipment and can be hazard to human. The leakage ground current is through the parasitic capacitor of PV array when the high or line transformer is omitted in the system. The objective of this research is to decrease and eliminate the high leakage current. The solution has been proposed such as switching technique, reduce the magnitude of parasitic capacitance, and designing a suitable filter on AC side. The leakage current is measured through the parasitic capacitor because the common mode voltage will appear and lead between PV array and ground. Figure 2 show the full bridge transformerless inverter. This transformerless inverter works with higher input voltage when compared to inverter with transformer. The performance and applicability are strongly influenced by the employed modulation scheme and the resultant voltage across the parasitic capacitor between the panel and the ground. The two types of switching technique strategy that has been used, which is bipolar and unipolar. The second method is parasitic capacitance. One of the important issues in the transformerless grid-connected PV systems is the galvanic connection of grid and photovoltaic system, which is led to the leakage current problem. The parasitic capacitance value is depending on many factors, which is PV panel and frame structure, surface of cell and distance between cell, model frame, weather condition, humidity, dust or salt covering the PV panel, and the type of EMC filter. And the last method, which is AC filter. Low pass filter at AC side of transformerless inverter is meant to reduce current harmonic injected into grid and system losses by the leakage current production when SPWM unipolar is used. So the methodology, the simulation circuit of the single phase transformerless inverter, as we can see in figure 8, using MATLAB Simulink, the circuit is modified from the existing pre-installed simulation circuit of single phase grid connected inverter inside the Simulink. As we can see based on the table 1, the parameter listed here are fixed at the simulation circuit. And furthermore, the table 2, as you can see, the parameter that will be changed in the simulation to be tested for the performance. So for the result as follow. Based on Table 3, the comparison graph of average leakage current IG and common mode voltage changes for each variable parameter are projected as shown in figure 9. As we can see from figure 9, it is clearly shown that leakage current is high when the common mode voltage changes is large, with the largest leakage current and common mode voltage are from unipolar PWM with parasitic capacitor equal to 16 nanofarad, and the leakage current significantly decreasing in half and common voltage decreasing by 10% when the parasitic capacitor is reduced to the quarter. Then the leakage current is reduced almost in half when the inductor filter value is double and the corresponding common mode voltage slightly decreased to 2%. When the PWM switch to the bipolar type with a double unipolar frequency, the common mode voltage changes is very small and the leakage current is almost non-existent. This confirmed with the analysis done by the research paper before that state the common mode voltage is constant due to the modification of modulation strategy. The leakage current is reduced or eliminated and further validated by the common mode voltage and leakage current waveform from the simulation for both bipolar and unipolar as shown in figure 10 and figure 11 here. The RMS value of the common mode voltage for bipolar is equal to 230.4 volt, while leakage current value is almost zero. Result and discussion. The highest leakage current on unipolar PWM is contribute to superimposed high frequency signal effect on the common mode voltage compared to the bipolar PWM, which has a sinusoidal waveform with the amplitude of VAC divided by 2 at line frequency as stated in Ma et al. Papers 2009. From the figure 14, the efficiency of unipolar PWM is slightly increased by about 0.5% compared to bipolar PWM despite provided almost non-existent leakage current. For bipolar PWM to match similar efficiency performance of unipolar PWM, its frequency need at least to be double of unipolar PWM. Thus, it brings the advantage of filter design and selection of power electronic component for unipolar PWM transformerless inverter, as it requires small sizing of inductor and capacitor filter and low cost switching transistor, as it operates much less of switching frequency compared to bipolar PWM technique. For the effects of parasitic capacitance on unipolar PWM, there is a slight increase of efficiency about less than 0.5% when the parasitic capacitance magnitude is reduced to a quarter despite a significant reduction of leakage current about half. This shows the efficiency increase is insignificant on unipolar PWM with decreasing parasitic capacitor value, but the significance of the parasitic capacitance factor to the leakage current need to be considered seriously in designing the unipolar PWM transformerless inverter. So for the effect of inductor filter on unipolar PWM, there are significant increases of more than 1% efficiency when the inductor value is doubled from 4 millihenry to double, which means to 8 millihenry. And the leakage current also significantly reduced in half. The significant increase of efficiency is not only caused by the reduction of leakage current due to the changes of the filter impedance, but also come from contribution of grid voltage and current ripple reduction. This reducing total harmonic distortion of the power delivered to the load as validated by the V-grid RMS and I-grid RMS waveform from simulation as per shown in figure 15 and figure 16 here. So the conclusion and the suggestion is this simulation present the comparison and analysis of various recently proposed single-phase transformerless PV inverter topologies. It is shown that 3 strategies has been commonly used for reducing leakage current and also increasing efficiency of transformerless PV inverter. Factors such as a parasitic capacitance of the PV array and the PWM switching method used and the filter design must be taken into consideration to design the transformerless PV inverter in order to achieve minimum leakage current according to VDE 415 standard, which is the Germany standard, and at optimum efficiency. Yeah. So that's for all. Thank you for listening.